the slides. Okay, I will look at the YouTube.
I see the
I can
presentation.
see your presentation, but so
Go in full screen.
somebody cannot see.
Go in presentation mode.
Wait a minute. Okay, can you see my? Okay, okay.
Yes.
Okay, sorry. I start my presentation. Sorry. Thank you for introducing our talk, optimization of multiple operation area decomposition using Ozaki scheme. This work is joint with Taiga Utsugiri, but he has already worked as one high school teacher in Shizuoka Prefecture. Now that is we show the abstract of our talk. First, our purpose of this study and the software layer of our optimized multiple operation linear computation library, BNC MatView. And after that, I show the result obtained by a benchmark test of optimized multiple operation matrix multiplication. And after that, based on the result of our optimized multiple operation matrix multiplication with Ozaki scheme, we will show the result of optimization of LU decomposition. And after that, we show the future works. Now that is we are developing optimized multiple operation matrix multiplication library and related multiple operation linear computation functions. This table shows the current status of optimized multiple operation matrix multiplication libraries. As described, this figure as the figure described, our result obtained by joint work with Utsugiri shows acceleration of multiple operation matrix multiplication with Ozaki scheme. So we will confirm the effectiveness of Ozaki scheme to LU decomposition. Sorry. Now this is a previous result our study. We have already confirmed the we have already confirmed the result obtained by result by using Strassen matrix multiplication library multiplication to LU decomposition. But in our previous works, we cannot accelerate. We could not accelerate LU decomposition by using optimized Strassen matrix multiplication. So currently, our accelerated row-wise LU decomposition. That means normal LU decomposition is the fastest LU decomposition in our library. So we want to try to accelerate LU decomposition with Ozaki scheme. This figure shows the software layer of our BNC MatView software library to compute multiple operation linear computations. Our all floating point computation is supported on CPU, and our this library's functionalities are limited, but they are faster than MP LPAC and MP Plus libraries by Nakata at Riken. In multiple component way, fixed precision arithmetic is supported and it's constructed with original ANSI codes that supporting double precision, double precision, triple double precision, and quadruple double precision. And of course, multi-digit way arbitrary precision arithmetic is supported, and that is based on MPFR library. By using our BNC multiple library, we can serial multiple precision computation is runnable on a Python ecosystem. This slide shows our targeting floating point precision, double, triple double, quadruple double, and MPFR arbitrary precision arithmetic. These three kinds of fixed precision are can be accelerated by using AVX2 instructions. Of course, MPFR in MPFR arbitrary precision floating point arithmetic, our library can be faster than MP Plus and MP LPAC function, because we in our library we can we directly calling MPFR functions. So we can get about 10% faster than MP Plus and MP LPAC libraries that are based on MP C++ class library that include some overhead of class library, and we can support two matrix algorithms. One is Strassen algorithms, and another is multiple matrix multiplication with Ozaki scheme. Both algorithms can reduce the number of matrix multiplication, but for in Ozaki scheme, the performance depends on the maximum the number of maximum decomposition of matrix A and matrix B, and short precision XGEM functions. For example, in matrix A and matrix B can be divided into three parts of short precision matrices, and so we can matrix product C by with three divided matrices by using short-term matrix multiplication like this. So the performance, Ozaki scheme's performance can be confirmed through a benchmark test for real matrix multiplication. Our computing environment are following. We use Xeon environment, and on Xeon environment we use Intel compiler and MP LPAC and MP Plus library. For Intel compiler, we use this option to accelerate our optimized multiple precision linear computation with AVX2. Now, this slide shows the result obtained by a benchmark test for matrix multiplication with Strassen and Ozaki scheme, and also NP plus real NP plus functions. In this figure shows our Strassen matrix multiplication are faster than NP plus RGM functions, and multiplication matrix multiplication with Ozaki scheme can be faster, much more faster than Strassen matrix multiplication like this. So and in maximum relative errors of matrix products, Ozaki scheme can be the most accurate numerical products by using maximum the number of divisions. In MPFR arbitrary precision arithmetic, Ozaki scheme can be faster than Strassen matrix multiplication in 256 and 512 bit precision arithmetic. But in 768-bit MPFR precision arithmetic, Ozaki scheme cannot be faster than our Strassen matrix multiplication like this, because these the matrix multiplication with Ozaki scheme can need to require more division of matrices A and B, and Ozaki scheme need to more computational time by using many DGEM functions. So we can get a quick summary of optimization techniques through these kind of matrix, these kind of benchmark tests. Ozaki scheme can be faster in middle range of precision. So in this area of precision, Ozaki scheme can be faster in LU decomposition and other related functions. So we want to confirm the performance of LU decomposition with Ozaki scheme. This figure shows the result of benchmark test result obtained from benchmark test with Ozaki scheme. In a double-double, triple-double, and quadruple-double LU decomposition on Xeon environment, Ozaki scheme can be faster than normal LU decomposition. But in double-double precision, the area where Ozaki LU decomposition with Ozaki scheme is very narrow, like this. So, but triple-double precision and quadruple-double precision, Ozaki scheme are very the area of where LU decomposition with Ozaki scheme are very wide, like this. So, middle range of precision are best ones for Ozaki scheme. As described in a previous result of MPFR matrix multiplication, LU decomposition with MPFR arbitrary precision, LU decomposition, the performance LU decomposition are similar with these previous results. In in 768-bit MPFR precision arithmetic, Ozaki ALU decomposition with Ozaki scheme cannot be faster than another kind of ALU decomposition like this. So that is shows the limit of application of Ozaki scheme to ALU decomposition. So we can conclude that Ozaki scheme is effective for middle precision ALU decomposition. This in double precision, triple double precision, quadruple double precision, Ozaki scheme can be fastest one. But in MPFR arbitrary precision arithmetic, especially in MPFR 768-bit, Ozaki scheme is not effective because in this precision, Ozaki scheme need 38 division of matrices A and B. So the number of core DGM function increase. So Ozaki scheme is not effective in this precision arithmetic. So based on this result through benchmark tests on the environment, we can expand our result to another areas of application. One is optimize complex linear basic computation and application to direct methods, including ALU decomposition in complex arithmetic. And we will implement a standard precision basic linear computation using multi-fold precision arithmetic that produce reproducible numerical result. And we also develop multiple precision sparse matrix vector multiplication. So based on this implementation of multiple precision SPMV, we can implement Kurilo subspace method with multiple precision arithmetic environment. That's all. Thank you for your attention. Thank you.
Thank you very much. So, is there any questions or comment? So I have a question about your last slide, the last point. So, you said you are developing the sparse matrix vector multiplication. So, but
yes.
the algorithm seems very different for the sparse matrix. So, what is the similarity and so the extension of your current work?
Yes. Good question. I already implemented multiple precision sparse matrix multiplication with MPFR arithmetic, and in MPFR arithmetic SPMV function can be very effective because directly we hope that the same acceleration with AVX2 instruction, we can accelerate fixed precision, double, triple, quadruple precision with AVX2 function as we can confirm that dense matrix multiplication and dense matrix vector multiplication can be faster than with fx2.
Thank you.
Sorry.
Is there any comment or questions? Okay, if not, so thank you very much, Koya-san.
Thank you.
So next speaker is, so Elise Dudonka. Are you here?
Yes, I'm here. Can you hear me?
Yes.
Okay.
Can you share your slide?
Okay. Can you see my screen?
Yes.
Yes, yes.
Okay. All right, thank you. My title is Computation of Three-Loop Integrals in Quantum Field Theory using Numerical Iterated Integration and Extrapolation. And I thank my co-authors Yuasa, Ishikawa, and Kato for their continued work and support. So I will give a representation of loop integrals and then address a case study for a particular diagram where we will outline the main methods. These are adaptive integration and linear extrapolation. So we motivate this work in view of improvements in the technology of high energy physics experiments, which then require that we apply theoretical predictions of commensurate accuracy. In order to obtain accurate theoretical predictions, we will use higher order corrections for the cross-section for particle interactions. We will use Feynman diagrams to address the higher order corrections. This gives rise to Feynman loop integrals that arise in the calculations. And there are symbolic numerical packages that address particular problems such as, challenging problems such as PySecDec, Fiesta, and MB numerics. We resort to numerical approaches since general and analytic treatment is not possible for general mass and momentum values. So we will resort to numerical multivariate integration methods where the number of dimensions is a factor in the degree of difficulty, and the difficulty increases with the number of lines and loops in the diagram. So here on top is a general representation of a loop integral with L loops and N internal lines. And so that is, you see the nu, which is the space-time dimension, and which is made a function of epsilon. Nu is 4 minus 2 epsilon. Then that gives rise to the integral being satisfying an asymptotic expansion in powers of epsilon, and we are interested in determining the leading term coefficients ck. In our case, we have k larger than or equal kappa, which is -3, and which presents a challenging problem. So here is a target diagram, as you see, with 3 loops and 6 internal lines. For the methods, we will apply repeated sector decomposition, and then the resulting integrals will be computed or are computed automatically. That is, the integration program is provided only with the integral specification and does not apply specific integration methods. Here is the integral with after substituting number of loops L equals 3 and N equals 6. And then we have split off a factor 1 over 3 epsilon, then another epsilon dependent factor, and then the integral J, which we are now interested in, which is listed as equation 3, and involves U and V that are polynomials. V is expressed in terms of another polynomial W. First, the variables x1 through x6 are transformed into y1 through y4, and then w1 and w2. That casts the integral j into integrations from 0 to 1 in w1 and w2, and then over the region R, which is sum of yj equals 1, in y1, y2, y3, and y4. All right. So the u then is expressed as a function of the y variables. The sector decomposition in the first phase divides the region R into 4 regions, R1 through R4, and eliminating of the delta function yields the integrals as 5-dimensional because one of the variables is eliminated. The second phase divides each region Rk into 3 regions, RKL, and the third decomposition divides each region RKL into 2 regions, RKLM. So we end up with 24 subregions, giving rise to 24 integrals, of which 6 are different. So we have to compute these 6 integrals, the J integrals. The JKLM is given in equation 4. So you see the integrations are from 0 to 1 in each dimension. And the functions G and F are safe functions. They don't involve any singularities. So the singularity is absorbed in the factor that involves the T and U to the exponents given in the denominator. Here is the table with the structure of the integrands for the different indices KLM. Looking at the singular factor times the age function that is given in the second column will give rise to J1 to 3 being of order 1 over epsilon squared, J32 and J134 of order 1 over epsilon, and then the rest of order 1. We will evaluate the integrals by repeated one-dimensional integration in each coordinate direction, where we will apply the quad pack routine, the dQAGSE in each direction. dQAGSE applies an adaptive integration algorithm and also has its own internal extrapolation strategy to address some types of boundary singularities. Okay, I'll go over the adaptive integration algorithm first. So this algorithm will subdivide the integration domains successively into finer and finer subregions, while termination conditions are not satisfied. The next region is retrieved from the priority queue, which is keyed with the absolute errors of the subregions. That region is split into subregions. The subregions are evaluated, the results updated, and the new subregions are inserted into the priority queue. Then, in addition, we apply transformations in the J integral. T is T1 to a power alpha and U is U1 to a beta, which yields, for example, for J1 to 3, a factor in a power of T1 and a power of T2, where we can determine the alpha and beta in such a way that these powers are positive, in other words, so that the resulting integrand function is no longer singular. So the extrapolation really obtains a dimensional regularization in the dimensional regularization parameter epsilon, which corresponds to obtaining the limit of a sequence of integral approximations QL as a function of epsilon numerically as epsilon goes to 0. The linear extrapolation strategy will really come down to solving a linear system of increasing size in successive steps. So assuming that we have, for example, an asymptotic expansion of the form that is given here, C0 plus C1 epsilon plus C2 epsilon squared, etc. The first linear extrapolation will use approximations Q of an epsilon 0, Q of the next epsilon value epsilon 1, and then truncate the asymptotic expansion after 2 terms so that we get a 2-by-2 linear system that can be solved for C0 and C1. Successively, then the order of the system is increased. Here we have a 3-by-3 in C0, C1, C2, and then eventually nu by nu to be solved for C1 through C nu minus 1. For the results, for the cat's eye diagram, with the massive internal lines, the masses are 1 and momentum is 1. We do intend to extend this to different S values in later research. For the results, we executed the runs on a multi-core system, but did not apply parallelization because the times were short. Okay, so the integral I is written as 1 over 3 epsilon factored out times integral J, and the J is a sum of 6 J integrals, and satisfies an asymptotic expansion of order 1 over epsilon squared, so that we are interested in determining C minus 2, C minus 1, and C0 of those. We use 2 approaches. In the first approach, we obtain the coefficients for the individual contributions, the J functions, and then combine the coefficients of the same order into the coefficients for J over 4. Here, in the second approach, we just take the sum of all the Q contributions. So we have a function Q of epsilon and evaluate or approximate numerically by extrapolation the limit as epsilon goes to 0 of Q of epsilon squared. So for the results of approach 1, for C minus 2, we have like 8 or so digits. The 0.25 is exact. And then for the rest, C minus 1 and C0, the contributions, for the contributions, we were able to generate reference numbers for comparison. and obtained about 5-digit accuracy. We can also compare two results by Laporta. For the results, here is an example just for one of the integrals, J123, using approach 1. So here we generate a sequence of Q123 of epsilon times epsilon squared. That's the input sequence for the extrapolation. That does converge, that does go to 0.25, but very slowly. So with the extrapolation, we get values, approximations for C minus 2, minus 1, and 0. And so we get about 5 to 6 digits for C minus 1 and C0, and more for C minus 2. For the approach 2 then, this shows a linear extrapolation for the sum function, the sum of the integrals as Q of epsilon multiplied by epsilon squared gives the input sequence for the extrapolation. The epsilon is a power of 1.067. It's a very slowly converging geometric sequence. So that to the minus L, L with the values shown in the first column. The times are short, so a couple minutes. And then C minus 1 and C0, again, we get similar accuracy as with the first approach. In conclusion, so we obtained results for a case study diagram with 3 loops and 6 internal lines. We used the sector decomposition yielding 24 integrals, where we have to compute 6 different integrals. We showed how to combine the sector decomposition with an extrapolation to alleviate singularities. We applied a linear extrapolation with respect to the dimensional regularization parameter epsilon, and used 2 approaches for the extrapolation by assembling the results in a different way. The second one was the easiest one to do, and so was efficient and also gave good accuracy. For the individual integrations that we have to do, we used automatic numerical integration, where no information about the function is supplied apart from the function definition itself. So this concludes my talk. Are there any questions?
Thank you very much. So I have one question.
Yes?
So last year I also heard your talk, and so the method is basically the same. What is the difference from the last year, and what is the new difficulties?
So we have a more difficult singularity with an order of 1 over epsilon, in order of 1 over epsilon to the third, which we handle in this case. I think last year it was 1 over epsilon squared. And
I see.
for the method, we used sector decomposition, which is also new for us. And so a contribution of this research is that we combine the sector decomposition with the transformation to diminish the singularity.
I see. So increasing the degree of singularity. So what is the difference in the numerical method?
So
Just
for
the problem becomes difficult.
Yeah, it is more difficult. So therefore, we applied the sector decomposition as an additional component in the numerical approximation.
Thank you very much.
Thank you.
Any other questions or comment? So if not, thank you very much.
Thank you.
Thank you.
So this is the last talk in this session. So the session, this session closes.
Thank you.
Thank you very much for technical support.
Thank you.
Thank you.
Thank you.
Bye-bye.
Bye.
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 Mi vedi? No, current break. Tu mi vedi? No.
Giorgia, io ti vedo.
Ah,
Prova a parlare.
mi senti?
Sì, ti sento anche nella cosa.
Ok,
Quindi
adesso provo
prova a,
a
prova a
senti-
condividere se te lo lasciano fare, se no niente.
Ma vedi che non vedo la mia presentazione.
Ma
Nelle
questo
file.
va, ci sarà, come dire, qualcuno che ti deve, secondo me ti devono dare
No.
l'autorizzazione, ma il fatto che tu possa entrare nella stanza è già a posto, che non c'è password, hai capito?
Sì, già quello è un buon punto, però quando
Ti
è una
devono
cosa.
dare loro l'autorizzazione alla presentazione.
No, non
No?
credo. No. Allora, aspetta che provo. Spero che non stiano registrando. Così.
No, spero di no, insomma, non è che stiamo dicendo brutte cose. Eccola, vedo adesso, come ieri, non vedo, fai partire, eccolo, perfetto, prova a mandare avanti le slide. Ok, funziona?
Ok, e tu mi vedi? Continui a vedere?
No, non ti vedo più, vedo solo le slide.
Vedi solo le slide. Ok, va bene così, insomma.
Ottimo, buon lavoro.
Grazie, ciao.
Good morning, everyone. We are starting session 12I. Give me a second. Can you hear me?
Yes, I can.
Okay, good. Good morning, Natale. So, Eleni, it's okay?
Good morning.
Let me check the program. I need the glasses. Okay. So, the session is related to the general track number 2. The first speaker is Collazos Morales. I cannot see connected, so I assume he will not present. The second author is Sonali Botke, even not connected. Okay, the only speaker present is Giorgio Bressan, I guess. Eleni, are you presenting instead of someone? Eleni? Non so. Prima l'ho sentita quando parlava.
Questa è la stanza 9.
No, la 12.
Lì si...
Ah, no, 12.
si sono
Lei sì, no. No, no. Eleni, are you an attendee or are you speaking for some? You are presenting one of the papers? Because I cannot find your name.
Audio.
It looks like Giorgio is the only people that will present. Giorgio, can you take the floor, please? Giorgio, okay. Your mic is muted.
Hello, can you
Okay.
hear me?
Yes.
Okay, perfect. So I will share now my presentation.
We see your slide. Thank you.
Thank you. First of all, I would like to thank the organizers for accepting this contribution for oral presentation. I am a researcher in geography at Tor Vergata University of Rome, and today I am presenting the results of the work that I conducted in the latest year with my colleague Gian Pietro Zaccomer of the University of Udine on cross-border shopping in the Italian northeastern border zone. I would like you to read carefully the title of our presentation as in the following 3 slides before explaining the objective of our contribution. I will focus on the...
Georgia, we don't hear you anymore.
I don't know what is the problem. I will interrupt the presentation. Can you hear me now? I don't know what's the problem. My mic is open. I will try to, can you hear by chance now? Can you hear me now?
Georgia, can you try to speak again? I changed the speakers of the aula.
Hello, can you hear me?
Okay, I can hear you. The speaker of the aula are dead. I'm using the speaker of the notebook. Sorry for the problem. So please go on.
Okay, we'll start again the presentation. Okay, so can you hear me? Can you see my slide?
Yes, yes.
Okay, perfect. So I was saying that I would like you to read carefully the title of our presentation, because in the next 3 slides, before explaining the objective or our contribution, I will focus on the Italian northeastern border zone, on the regional fuel market, and on COVID-19 pandemic. So our analysis focus on the Friuli Venezia Giulia region, an Italian administrative region of about 1.2 million inhabitants. It is located in the eastern part of Italy, and its northern limit with Austria is marked along its entire length by mountains, while its eastern side is a hilly region and borders with Slovenia. This consideration is rather important because it means that there are favorable geographical conditions that facilitate human habitation in this area and interaction with the nearby country. This study of the fuel market is relevant here because the Italian national government levy fuel heavily, with negative consequences for consumer prices. Spatial differences in fuel prices is felt especially in areas surrounding land crossing, and clearly the administrative region of Friuli Venezia Giulia, there is such an interesting case where to assessing the impact of border closure of the international terrestrial border on the fuel market. As you can see in the third figure, this is an example of the first competition with Slovenia. In fact, you can notice that in close proximity to the international border in the Slovenia city of Cezana, there are a series of filling stations that are strategically located in order to attract Italian customers. However, there is an important note to make that is there is in force a regional policy aiming at preventing the purchase of foreign fuel. In fact, since 1997 in this region, there is in place an economic policy aiming at prompting local residents to attend regional filling station. At the outbreak of the pandemic, there was enforced the regional law 14 of August 2010, which is in force since late 2011, according to which residents were eligible to request a contribution for the purchase of fuel at any regional filling station. Motorists residing in municipality pertaining to the area 2, so the yellow color, were eligible for ordinary contribution, while those residing in the municipality pertaining to area 1, so orange color, were eligible for an increased contribution. As you can see from the map, Area 1 encompasses the municipality bordering the international borders, but also other inner municipalities that are far away from the international border. Those are considered disadvantaged according to a series of national and European regulations. That is why they are included in the set of municipality where residents are allowed to ask a greater contribution for the purchase of fuel. And here we want to remind some features of the COVID-19 pandemic for Italy that are relevant in this contribution. That is that the national territory was subject to a nationwide lockdown, and the measure severely affected individual mobility, but first, essential movements to carry out essential activity were still allowed. And second, while in general business was closed, essential service were open, and that was the case of filling station. The second important point to remember about the pandemic is that the measure adopted by Italy to contain the spread of the coronavirus and those taken by neighboring states created a temporary impermeability of the international terrestrial border, so that travel for the sole purpose of tourism was prohibited, as it was those clearly related to shopping. Well, what are we doing in this contribution? The decision to attempt to curb the diffusion of the virus with such strong form of impermeability of the international border has determined an unprecedented situation. So there is the need to study whether the impossibility to cross the border to shop favored an increase of sales of fuel in the high-tech station country, even in a context where movements of the people were limited due to the stay-at-home policy. So the main research questions are, was the 2020 COVID-19 lockdown a friend of fuel or the regional fuel market sector? And secondly, did the regional government take this context of crisis to rethink its policy action with the aim of reducing further the incentive to shop abroad. The relevance of this topic is quite remarkable for at least 3 regions. First, the border closure is an exceptional event and impacted on motorists living in proximity of the border. From here, there is the need to reflect on whether it has temporarily advantaged the trailers operating in border areas of the high taxation country. The second reason is the relevance of the topic is because of the societal impacts. If a lower demand of fuel is registered, it has consequence not only for business in terms of less sale, but also for the states in terms of lower fiscal revenues. Third, in general, the topic of cross-border shopping has strong environmental impacts because cross-border shopping is polluting as motorists driving gasoline or diesel cars are willing to travel more in order to save in terms of fuel cost. In order to perform our analysis, reply to our research question, we made use of different data set provided by different authorities. We use the data provided by the Ministry of Economic Development, which is responsible for the publication through its oil bulletin of monthly data concerning the quantity of fuel sold at province and regional level. Secondly, we made use of the dataset provided by the Friuli Venezia Giulia region. That is because due to the existence of this economic policy aiming at preventing the purchase of foreign fuel, there is a monitoring system of the quantity sold at regional level that consider different geographical extent compared to those analyzed by the ministerial bulletin. So here we want to present some results of our analysis. First of all, we want to show that the trend in sales of automobile fuels. The data regards the period from 2012 at the outbreak of the pandemic. As I've mentioned, there was enforced the regional law 14 of August 2010. That is in force from late 2018. As you can see, there is a progressive decrease in the quantities of gasoline sold at reduced price for both contribution areas, so areas 1, area 2, while that full price is increasing even in 2020. A possible explanation of the growth of gasoline purchase at full price during 2020 is that those purchases are made by motorists that were used to go abroad in order to refuel, but in this period is forced to buy gasoline at a regional petrol station. The other observation is that for diesel, there's a continuous growth in the liters sold, both at reduced price and at a full price, with exception of the setback caused by the 2020 pandemic. Here, we want to highlight the impact of the pandemic on the quantity sold. The overall annual reduction between 2019 and 2020 in gasoline and diesel were very similar, with around 10%, but the contractions for diesel is in absolute terms of 36.8 million liters compared to the 24 million liters of gasoline. The reductions in liters sold is much stronger for fuel at a reduced price, in particular in the area with ordinary contribution compared to those at full price. The sale of full price gasoline even increased by almost 9%. The other data that we want to present are those from the ministerial bulletin. Here we can see that data are disaggregated according to the province level. And we have also the quantities sold in total at regional level and at a national level for 2019, 2020, and 2021. So in the Friuli-Venezia Giulia region, the sales of automotive fuel in 2020 compared to 2019 underwent a reduction that is lower than the one record in Italy, both for gasoline and for diesel. You can see, for instance, the drop is of 13, almost 14% at regional level, while at national level the drop is of 21% for gasoline. But if we look at the sub-regional level, we can see that in 2020, the province of Gorizia and Trieste, which are those that are closest to the borders, to the Slovenia border, so those are the areas that suffer most from the international competition. Unlike those of Udine and Pordenone, have registered increase in sales equal to 10% and 30% for gasoline and almost 20% and 33% for diesel, respectively. When 2019 is taken as the baseline, the increase in sales during 2021 for the province of Gorizia and Trieste are remarkable than compared to the regional and national one. Those increases are of 36% and 69% compared to the regional value of 1.1% for gasoline and 45.9% and 72.7% compared to the 2.4% at regional level, while at the national level there is a contraction of 2.8% for diesel and a contraction of 3.9% for gasoline. So summing up, the temporary either attendance of a regional filling station in comparison to the average situation recorded in Italy highlights the strong international competition that business operator of the high taxation country usually face in this border area. Our findings highlight that the filling stations located in the province of Trieste and Gorizia were less affected by the lockdown. In this area, the lower mobility and the consequent lower demand for fuel was offset by the purchase by the new local customers. That is the one that usually go abroad in order to refuel, but in the context of the pandemic couldn't travel abroad. And then it's also important to note that there is, however, a regional contraction that derives from the fact that despite the boom in sales in the border province of Gorizia and Trieste, those two provinces matter less in terms of absolute fuel sales than those of Pordenone and Udine. We have presented some findings concerning yearly quantity sold, but we should remind the context in which those data were registered, context that influenced the market outcomes presented. In fact, beside the decision of the economic actors, in this market are relevant the actions of institutional actors such as the neighboring states and the regional government. We don't have time to present the entire chronicle, but we would like to remind what happened after the reopening of the border. The government of Slovenia modified its excise duty to allow the local filling station to charge a price just below the threshold of €1 per liter, while Austria, as you can see from the picture, regulated itself in such a way to charge a price slightly higher than the unit price. There was a reaction by the regional government in Friuli Venezia Giulia with the opening of crisis talks with all the actors involved in the market. And it was proposed to bring for the contribution area 1 the contribution to 29 cents per liter for gasoline and 20 cents per liter per diesel. And the agreement was reached, and the increase in contribution was operationalized from the end of August 2020. Well, in order to conclude, we have seen that the border zone is a particular geographical context. In fact, from the supply side, the state and other institutional actors have the power a strong power in determining the directions of motorist trips and the fate of the local fuel market. And this creates uncertainty of international of companies and local operators who need to ponder even more carefully the possible decision of locating one of their stores in such a variable environment. The border zone is a particular geographical context also for the society, because under normal conditions, residents of the border zones consider living in a unique borderless context. But during the lockdown, cross-border trips to shop abroad were not possible. As a behavioral change occur, or will it remain? This is an open question for future research. In addition, does it worth to continue focus our attention on this particular case study even after COVID-19 and that exceptional situation constituted by the border closure? Well, the answer is yes, for at least 2 reasons. Well, in last year, there was a fuel price reduction introduced by the Italian government in response to the economic effect of the 2022 invasion of Ukraine by Russian troops. So there is another shock in the market. And secondly, at the beginning of this year, the regional legislator has amended again the legislation on the purchase of regional fuel. And the main novelty is that it was introduced an additional contribution that only borderland residents can request. And in order to perform analysis of the impact of such events is again a fundamental the availability of fresh data. And because they are fundamental for determining the effectiveness of regional policy in force and also the implication of the decision taken by national governments. Data that at the moment are not available and prevents further analysis. Well, thank you, and I am open to questions. Thank you.
Thank you too.
Thank you to you. Okay. There is no one in the audience, so what are in your opinion the main goal of your research? Summarizing briefly.
Well, the main goal is to understand the risk of operating in a border zone, because with our data, we analyze data concerning the Italian situation. We are not able to say to make some reflections on cross-border shopping because we don't have data. We didn't analyze data of the other sides of the border, so we don't know how were sales in those contexts, even because the patterns of the decision taken by the various national governments in terms of lockdown mobility were different. So there are different impacts on motorist behavior. But with our data, we can say that the closure of the border allowed regional filling station by the border to sell their product to customer, to either share of customers that were probably used to cross the border to refuel. So it highlights that the open permeable border that is of course positive for the economy, for the social interactions, for the institutional interaction, is in any case an enemy for business operator in normal condition, because it's adds further risks that filling station located in inner part of the country do not have. That is international competition.
Okay, thank you so much.
Well, thank you.
So I guess we can close the session because the other speakers are not present. So thank you, Giorgia.
Thank you for hosting.
Bye-bye.
Have a nice day. Bye-bye.
Bye.
Bye.